Hi, I'm Michelle Woods, and I'm a second-year master's student at the Virginia Institute of Marine Science. At VIMS, my research focuses on harmful algal blooms in the context of nutrient cycling in coastal ecosystems. I'm excited to share my lesson plan with you, which focuses on harmful algal blooms, what they are, their causes, and how they are harmful to both ecosystems and humans. To begin this lesson, the teacher will collect water that contains natural abundances of phytoplankton, or add algae grown from an algae culture kit to water that is already set aside for this experiment. Each group of students will have 3 bottles of water. One bottle of water will be filled with DI or purified water. The second bottle of water will be filled with water that contains algae and no fertilizer. And the third bottle of water will be filled with algae and fertilizer. Each group will use a different amount of fertilizer so that they can compare how, at the end of the lesson, how different amounts of fertilizer change phytoplankton growth. In this picture here, I have 3 bottles that contain fertilizer and water with algae, and each bottle contains either 1, 2, or 3 tablespoons of fertilizer. The students will take pictures every day of their bottles for the duration of the experiment to compare either color changes or the changes in the number of bubbles observed in each bottle, as both of these signify phytoplankton growth. If there is not a lot of phytoplankton growth within the first 5 days of this experiment, the teacher has the option to extend this experiment for another 5 days to ensure that students see adequate phytoplankton growth. The students will then take their pictures and learn how to translate qualitative data into quantitative data using this graph and table below. The color or the number of bubbles in each bottle corresponds to a specific number on the graph that then corresponds to a specific phytoplankton abundance. Here I have a mock graph showing what this data might look like. As you can see, in the bottles that contain purified water, there is no color or no bubbles most likely observed, so this corresponds to no phytoplankton. In the bottles that have water with just algae in them, there will be a low abundance of phytoplankton in these bottles that probably won't change very much throughout the duration of the experiment. And this is graphed as a 2, so there is low abundance of phytoplankton. And finally, the bottles that contain both algae and fertilizer will show a change in phytoplankton abundance throughout the duration of the experiment, and that change is shown in this example here, where at the beginning of the experiment there is low abundance of phytoplankton, and by the end of the experiment there is a high abundance of phytoplankton. The students can then come together to graph their final day data as a class. They can graph their DI water data, their water that contains algae and no fertilizer, and then their last day pictures of water that contains both algae and fertilizer to see how different amounts of fertilizer change how phytoplankton grow, and start making connections between what causes harmful algal blooms and perhaps how we as humans can mitigate the occurrence of harmful algal blooms. Thank you, and I hope you and your students enjoy learning about harmful algal blooms in your classroom.